Good afternoon, everyone. I'm Christian, and it's a pleasure for me to stay here and present my article, the design and mixed reality teleoperation of a quadruped manipulator robot for SAR tasks. This work is part of the SAR project. This is the team of advanced search and rescue robots. This is a national project that seeks to develop new robotic approaches to inspect post-disaster environments. As objectives of this presentation, we have that the first one is to design and optimize the workspace of a robotic set, the quadruped and the manipulator. The second one is implement the optimized model in a simulator. In this case, we use Gazebo because it allows us to evaluate different kinematic and dynamic parameters. The next one is to develop the integration, the mechanic and electronic and control algorithms for the robot assembly. And finally, we have the design, the teleoperation system through mixed reality for high-level control. As a previous motivation, we have that in the last 20 years, according to the United Nations Office for Disaster Risk Reduction, there was around 7,000 natural disasters and around 1.23 million of deaths. And in this figure, we can see the countries that integrate the Pacific Ring of Fire, and these countries are susceptible to have an earthquake or an eruption, a tsunami, and the possibility to have a post-disaster environment, such as in these places that, for example, in the USA, with the Twin Towers in 2001, Japan in Fukushima, or Italy or Mexico, there was a participation of robotic teams to inspect and to help the rescue teams to evaluate the conditions of the environment and take previously data to identify if there is a victim inside this environment. Within the state of the art, we can see that in recent years, there is something new works developed with quadruped and manipulator robots, such as in these cases. These articles were presented previously in some conferences. They uses the platforms in these two first cases uses the animal platform, and the last case is the Boston Dynamics robot. Regarding to the teleoperation, also in the state of the art, we have some works that aborded these topics. For example, in
the Institute of Technology presented its new teleoperated robot at the ICRA 2021 conference. The robot combines the strength and power of its predecessor
and uses a virtual reality system for teleoperate the quadruped manipulator robot.
The Institute of
Okay, within the state of the art, we have a great increase inside the research topic for quadruped robots and search and rescue, and this is an exponential increase, such as, for example, in the DARPA Subterranean Challenge. In last years, some teams implemented quadruped robots for the main exploration. That is the case of the last year's DARPA's challenge. Okay, for this work, we have used these elements for deployment the system. The platform used was the Uni3. This robot's name is Arthur. That is A1 Rescue Task UPM robot. It has different elements, sensors. It has an RGBD sensor, laser sensor, and for data processing, we have used Jetson Xavier. Also, the robotic arm was the commercial Trojan robotics of 6 degrees of freedom. It has a payload of 300 grams and a weight of 3 kilograms. And also for teleoperation, we have used the HoloLens from Microsoft, the first one generation. We started from the design of the workspace to analyze the better workspace to operate with the arm. We have used MATLAB, and we started from the direct kinematics. Here we can see in the graphics the different zones that the robot arm can reach. In that case, the red zones are all points that we can reach, but it's not recommendable to work within the end of these points because it has a lot of high torques that couldn't be good for the system. we have implemented a solution that avoids the collision with the front and the back of the robot that is described in the green zone. After that, we implement the solution in gazebo, as we said. Here we have the diagram with the four legs connected, and the reference system was the central body. The robotic arm also is described there, and the sensors too. In this case, we can see the gazebo simulation and the RB's control that we have used. As in this video, we can see how the control is integrated for the quadruped robot and the robotic arm. We use Move-It to perform collision-free trajectories. So in this case, we are giving a point to the effector, and here we can see how Move-It performs the free collision path, and we can see how it moves in gazebo. Here we can see the movement in the real robot with other points. And finally, to control this at a high level, we have implemented the teleoperation system. In this case, we use the software Unity to the interface. In that case, we place the virtual model with a control in the end effector. Is a blue ball that the operator is able to manipulate. And these commands of the articulation are sent to the low-level control in the real robot that is in Rose Melodic. Here we can see how the system functions. So here we can see the first-person view of HoloLens and also an external view of a GoPro camera. This is a task of pick and place where we can train to the operator to take an object and transport this object to another one. After that, we have performed different tests in laboratory sets that allow us to validate this method. The video is a little long. The interface also has different buttons, such as predefined positions, such as home, sleep, or other positions to transport the objects. This is another site where we make some tests. Okay. And finally, to validate or implement the method, we have contrasted this with a conventional one. This is a conventional interface where we have the image transmitted and the position of the robot. And we use the mouse to give some points to move it. And main results are present here in this graphics. Graphic number 1 shows the immersive experience of the mixed reality against the conventional interface. And the second one shows the operator confidence of these two interfaces. In the evaluation test, the persons who did this test say that they have a preference for mixed reality interface because they have a first perspective of the task, and it motivates to do the decision making. And also the efficiency based on training, it shows that at the beginning, if a person doesn't have any kind of experience with these interfaces, it is not good. But after some trainings, it becomes better and to perform any task. Finally, as conclusions, that we have that the implementation of the Cuadruped-Manipulator joint kinematic modeling in MATLAB has allowed calculating and optimizing the work area. And also that the ROS simulation environment has shown a great potential and utility to represent conditions and integrate the model design. And the mixed reality interface versus the conventional interfaces have shown great potential, mainly in the increase of operator confidence. and that the proposed method seeks to approach with less invasive hand sensors for teleoperation, as well as low cost concerning others within the state of the art. And regarding future works, we are now working in a collaborative perception. Here we use a virtual reality environment to do this task, but we have a feedback of the image transmitted by external robot that give us the perspective to approach to the task. This is an external test. The operator takes a first date, and after that, it identifies a victim using a neural network and goes to receive the victim. Thank you so much for your attention. Do you have any question?
Yes. Is there any question? No one? Okay, I have some ones. First, have you evaluated the latency between the robot communication and mixed reality system? Is there?
Yes, we have evaluated that, and at this moment, it's not in real time because we have communication with a network or with the HoloLens. It has a 2.4 gigahertz communication, and the robot is with a 5G network. So we have to use a converter. And for that, we have only developed the small movements to do between the glasses and the robot arm.
Okay. And how do you have set the reference for the simulation in the reference joint for the motion of the robot in the simulation?
Yes, we have, as I said, we have predefined positions. And we start from that, and then we receive and transmit the position and to get an estimation of the position in each moment.
Okay. And the other question is, it will be applied in real time in the future. We hope so. So how do you deal with to avoid with navigation? So to avoid and
yes, yeah. In this case, this is teleoperated, but there is a new another objective to do this in an autonomous way. And another thing that we are trying is to use the HoloLens 2 that it has a 5G network also to try to solve this latency that we have with the other glasses.
Okay, thank you.
Thank you so much.
Thank you for your time. So let's thank you again.